Hi, I'm Jennifer. I'm an astrophysicist with NASA's Hubble Space Telescope mission, which observes the universe. This is Ask NASA, and I'm here to answer your questions. The Hubble Space Telescope has been operating for 30 years, but it's still very powerful. I think we humans have a curiosity about how we fit into the natural world and how our planet fits into this much larger universe. We have a lot more to learn, and one of the things that Hubble has told us through its observations is that our universe is really active and dynamic. The galaxies, the stars, the planets are not just sitting there stagnant. We actually have learned through Hubble observations that stars are still forming in these interstellar clouds. We've learned that our own solar system is incredibly dynamic. One of the earliest observations from Hubble showed a comet crashing into Jupiter. We've discovered actually that the moons around planets in our own solar system are interesting places in their own right. Hubble found evidence for water vapor plumes being ejected from the surface of the moon Europa around Jupiter. So Hubble continues to be at the forefront of astronomical exploration. We're looking at what we call exoplanets. So exoplanets are planets that are orbiting stars other than our sun. And Hubble is actually finding water vapor in the atmospheres of some of these exoplanets. So that's a hot topic for Hubble study right now. On the bigger scale, we were very surprised when it was determined that the expansion rate, that is the rate that space is stretching and the galaxies seem to be moving apart from each other, is increasing. In other words, the universe expansion is accelerating. Now, we don't know what would cause that. Matter in the universe tends to have a gravitational pull that pulls things back together, or at least would slow down this expansion, not speed it up. And so we call it dark energy, this mysterious phenomenon that seems to be accelerating the expansion of the universe. The Hubble Space Telescope receives commands transmitted up from the ground. So here at NASA's Goddard Space Flight Center, we have a control room where the telescope is monitored. We transmit commands up to Hubble that tell it where to point. The data are recorded, and eventually scientists will determine the answers to the questions they were trying to ask by taking these observations. Now, the images from Hubble that most of us really enjoy looking at, these images of galaxies and nebulae and stars and planets, the websites like nasa.gov/Hubble and hubblesite.org host these images. They're freely available, and our exposures with Hubble are going on every single day, so we're still a very active observatory. Hubble is teaching us a lot about the universe, not only through looking at the colors that our eyes can see, but looking beyond that range of colors that our eyes can see. So our eyes can see the colors of the rainbow from violet to red. Hubble can see those visible colors, but Hubble can also see a little bit redder than red into the infrared part of the electromagnetic spectrum. And Hubble can see a little bit bluer than blue into the ultraviolet part of the electromagnetic spectrum. But a lot of things in space that we're interested in emit their radiation in those invisible colors. Now, one example is seen in the famous images of the Eagle Nebula. Now, with Hubble's visible light camera, you can see these dramatic pillars. If you look at that same region with Hubble's infrared camera capability, you can see through some of that dust. You see into those pillars. You see a lot more stars that were previously veiled. When the James Webb Space Telescope launches, we will be able to see even farther into the infrared part of the electromagnetic spectrum. So we're looking forward to having complementary observations to give us a lot more information about distant galaxies and about star-forming nurseries right here in our own galaxy. The Hubble Space Telescope can see deep into space, which is really looking deep back in time, because it's taken time for distant objects to have their light traverse space to get to us. Some of the galaxies that Hubble has seen are shining to us from millions of years in the past. And some of the galaxies that Hubble has seen have taken billions of years to get to us. We typically think in terms of light years instead of miles or kilometers when we're talking about deep space because the distances are so vast. But Hubble is seeing more than 13 billion light years into the distant past and into the distant universe, and that is truly awe-inspiring.